Okay, it's inverse functions video 10, video part 10. Uh, we reached here in the previous video, and x squared minus 3x minus 4 equals 0. We factorize them. It's x minus 4 into x plus 1, right? Taking each factor equal to 0. This is, again, was the trying to find intersection point between the curve and y equal x. And this helps me a lot to draw. So either x minus 4 equals 0, this means x equal 4, and this is an accepted value, or x minus x plus 1 equal to 0 implies x equal minus 1. This is a rejected value, because if you remember, f of x was defined on 2 open at 2 plus infinity, and minus 1 is not in our domain. So the only value is x equal 4. And since y equal x, if x equal 4, then also y equal 4. So let us take a point C of abscissa 4 and ordinate 4 as well, right? Now, let us try to draw. And I will try to tell you, or to mention here, we might not have. Let me first, before drawing, okay, let me try to draw the x-axis, y-axis first. Okay. Okay. Now, before I continue drawing, let me do the table of variation, right? Table of variation of this function x from 2 open at 2 to plus infinity, right? Derivative, remember, the derivative was, let's see, the derivative f prime of x, we found it was here, right? This is not derivative, this is the inverse. We didn't find the derivative. Yes, we did, here, right? Was minus 6 over x minus 2 squared. So also x should not equal to 2 in the domain of derivative. So at 2, what do we have? It's restricted value for f of x and for derivative as well, right? Now, as it's minus 6 over x minus 2 squared, the derivative. So it's minus. All the way it's minus, strictly decreasing. And it should be like that, right? Otherwise, we don't have, we will not have to continue to find the f inverse. So this one is f goes all the way from plus infinity. If x tends to 2, you can see, check out the limits in a previous video. It will go to plus infinity, and when x tends to plus infinity, it goes to y equal 1, which was a horizontal asymptote. And this one, x equal to, if you remember in the previous video, you should take notes from the previous video to continue this video. X equal 2 was a vertical asymptote. Okay, here we should be careful to draw. First, I prefer to draw the point C, which was, if you remember, 4, 4, right? The point of intersection for abscissa with 4 ordinate. Okay, let me draw first the y equal x before we forget. Y equal x, I just need this part of it, right? Y equal x, it's the first bisector. So 4, 4, 4, 4 should be a point. If we go all the way from 4 to the x-axis, and we go to the y-axis, right, like this, this is 4, and this is 4. This is one of the most important points I need to finish my drawing. All right? Be careful. Be careful here. Okay. Let me see what to do. We don't have endpoints, as you can see, because we don't have endpoints, because when we started this problem, we did what? We did find horizontal asymptotes. There's no f of 2, and there's no f of radical of plus infinity. There's limits only. So we have x equal 2 vertical asymptote and y equal 1 horizontal asymptote. We don't have points to start with. So that's why I should take some particular points. Some particular points. If we have another point, that will be really good, but we don't. Okay? We don't have endpoints. We don't have closed interval. All right. Let's start with taking some extra points, or drawing the vertical and the horizontal asymptote first. Vertical asymptote was at x equal 2, so it's here, right? Vertical asymptote was here, x equal 2. And this will be nice. I'll tell you what. This is the vertical asymptote, okay? At x equal 2 exactly. And y equal 1 was what? Was horizontal asymptote, right? Y equal 1 was horizontal asymptote. Okay, the asymptote, it's better to draw them as dotted lines, right? I don't know what happened. This is the horizontal asymptote. But here is okay now, right? Let me try to... Okay. Let's draw them as red lines, okay? Now, I told you before, and it is important. I told you in the property, you can revise the property. The property says, if x was 2 vertical asymptote, this means directly y equal 2 is a horizontal asymptote for the inverse. And if y was 1 as horizontal asymptote, then x equal 1 will be a vertical asymptote for the inverse. All right. Let's try to draw first before we do those. Let's try to draw in a different color. I will draw C in yellow. As x tends to 2 as a vertical asymptote, f of x goes to plus infinity. So as x tends to 2, you see this 2? You see this line? This line again? You see this line? X equal 2, right? And here y equal 1. When x equal 2, vertical asymptote, it comes from minus infinity all the way down, where y equal 1 is a horizontal asymptote. So it goes all the way. No need here to use the extra points. We go all the way, decreasing from the first asymptote to the second asymptote. This is the curve. Oh, sorry, we did some mistake here. It should pass through C because there's a point of intersection between it and C. Let me extend the asymptote a little bit. So it goes all the way down, passing through this point C, goes all the way, but it does not exceed this line because it is a horizontal asymptote, okay? It goes all the way. I'm trying my best, but it's really hard to draw on this tablet. Okay, this is the curve of the function. Now, how to find the curve? How to draw the curve of its inverse? The curve of its inverse: x equal to horizontal asymptote, then y equal to is a x equal to vertical asymptote, then y equal to is a horizontal asymptote. This is another asymptote now, but for the other curve, and y equal 1 was horizontal asymptote. Now x equal 1 is a vertical asymptote. We just changed them, right? We just changed them from vertical to horizontal, from horizontal to vertical. Okay? Now, same thing exactly. Same thing exactly for the curve C. I will try to finish because the time. Okay, it goes all the way now from vertical asymptote, or from vertical asymptote here, x equal 1, passes also through C, and it goes to the other asymptote. This is the curve of F inverse.